the first thing to do here is to write out the chemical equation showing the reaction between carbon 2 oxide and oxygen. So when carbon 2 oxide and oxygen reacts, we have carbon 4 oxide. And looking at the equation above, we discover this is not a balanced chemical equation. The next thing to do is to balance the equation before proceeding with the calculations. So here we have one atom of carbon, here one, and then for the oxygen we have 3, 1 plus 2, 3 in the reactant side, and in the product side we have 2 as well. So we need to make sure we have equal numbers of atoms of oxygen on both sides. So if we had 2 here as a coefficient, so 2 will be affecting carbon as well. So oxygen is now 4 and carbon is 2. So we'll be adding 2 again to balance carbon here. And then we have 2 atoms of oxygen plus 2, that's 4. So we have 4 on the reactant side and 4 atoms of oxygen on the product side. Now we have a balanced chemical equation. And to know the reactants in essence, we need to find the limiting reactant, that is the reactants that will be used up in the reaction. How do we get that? We are given the volume of carbon 2 oxide that reacted, but we do not know the exact amount of oxygen that took part in the reaction. And it was stated that 150 cm3 of air containing 20% of oxygen by volume was used. So let's calculate the amount of oxygen that was used in the reaction. So for 20% oxygen by volume, can then say volume of oxygen equals, since it is 20%, that's 20% of 150 cm3. In calculating this, we have 30 in the unit centimeter cube. So we've gotten the volume of oxygen that was used, and we know the volume of carbon 2 oxide. So we need to determine the one that was used up. If 50 cm3 of carbon 2 oxide was used up, what volume of oxygen will be required? And to know the volume of oxygen that will be required, let's state the ratio in which they are combining. Now you can say 2 volume of carbon 2 oxide will require 1 volume of oxygen. Then 50 cm3 of carbon 2 oxide will require x cm3 of oxygen. The 2 and 1 we used above is gotten from the chemical equation, and that's the reason we need to have a balanced chemical equation. So we are cross multiplying indirectly, so x will be equal to 50 cm3 multiplied by 1 volume divided by 2 volumes. So this is equivalent to 25 cm3. So that is, if we used all of carbon 2 oxide, the 50 cm3 of carbon 2 oxide provided, we will be needing 25 cm3 of oxygen. Then let's see, if all of oxygen gas was used up, what volume of carbon 2 oxide will be required. Then from there we can then conclude the limiting reagent or limiting reactant. So the volume of oxygen is 30 cm3. So in the ratio they are combining 2 volumes of carbon 2 oxide, they require 1 volume of oxygen. Then y, so we'll be using y now instead x so as not to be confused. So y cm3 of carbon 2 oxide will require 30 cm3. Don't forget that we are using all of oxygen here. So making y the subject, y equals 60 cm3. So now to know the limiting reactant, we need to see if we have enough of the volumes of the substance provided. Now let's see for oxygen. If we used all of carbon 2 oxide, we have 25 cm3. Meanwhile, we are provided with 30 cm3. That means we have enough of oxygen to be used. But if we used all of oxygen, 30 cm3, we'll be needing 60 cm3, and we are not giving up to 60 cm3 in the question. So that means oxygen gas cannot be the limiting reactant. That is, we cannot use all of oxygen gas, hence making carbon 2 oxide the limiting reactant. That is, we'll be using all of carbon 2 oxide. So if we use all of carbon 2 oxide, that is 50 cm3 of carbon 2 oxide is used up, be requiring 25 cm3 of oxygen, which means that oxygen will still be in excess. And that answers the questions that oxygen gas is the reactant in excess. So in some cases we might be asked to calculate the amount of gas or substance that was in excess, so we can proceed to calculate the remaining one that will be left. But here we are just asked to determine the substance or the reactants that will be in excess. This implies that oxygen is the reactant in excess. With this, we've come to the end of the solution to the question above, and the reactant in excess is oxygen. That will be all. Do not to subscribe for more if you find this video helpful.